All right, now let's take a minute, and what we're going to do next is we are actually going to graph logs. Now, it's not going to be as hard as you think, so what I want you to kind of remember here is that logs and exponents are inverses of each other. So if you know how to graph an exponential function, then you're going to know how to graph a logarithmic function because they're inverses of each other. And remember, what do inverses do? Inverses switch the x and the y value. All right, so let's first start off by graphing the graph y equals 10 to the x. And now here's what we know. Number one, before we even graph this, we're going to graph our horizontal asymptote. Okay, remember that's your number added or subtracted here. So let's graph our horizontal asymptote of y equals 0. All right, and we can go ahead and plug that in right here at the bottom, okay? And then what could we do to graph this? So we know exponentially this graph is going to be going up. Let's find our y-intercept. So if I just make a super quick table and find two values, let's plug in x is equal to 0. And remember 10 to the 0 is just equal to 1. So that gives me a y-intercept of 0, 1. And then let's plug in a super easy point of 1. 10 to the first is equal to 10. So 1, 10. All right, so let's just take a second and draw this graph and answer the questions about it before we move on to graphing logarithmic functions. Okay, so we know the domain of all exponential functions are going to be negative infinity to infinity. The range in this case is above your horizontal asymptote. So since it's above it, the lowest point is 0. So 0 to infinity. All right, and then what's our y-intercept? Well, we already graphed that right here. There's our y-intercept is going to be 0, 1. Okay, and since this is an exponential function, it's actually increasing at an exponential rate, which kind of makes sense, right? Okay, so now let's take a minute and think about what my logarithmic function is going to look like before we even graph it. Okay, now number one, what we do know is that they're inverses of each other. Okay, so inverse means you're switching your x and your y. So if you have an exponential function and it has a horizontal asymptote of y equals 0, that means my logarithmic function is going to switch your x and y, is going to have a vertical asymptote at x equals 0. Okay, and we'll talk about what all this means in a minute, but so that's going to tell us that I now have a vertical asymptote at x equals 0. Now let's fill in our domain and ranges before we actually even graph it. So remember that domain is x and range is y, and inverses actually switch the x and y. So the range of your exponential function becomes the domain of your logarithmic function, which now we know the domain is going to be 0 to infinity. The range of your logarithmic comes from the domain of your exponential. So we know that our range is now going to be negative infinity to infinity. Now, before we graph this, let's just think about what that means. So our domain, that means my graph is going to be entirely in this quadrant, your first and fourth quadrant. My range is going to go up and down infinitely. So now let's think about what our x and y intercepts is. If this was a y-intercept, remember inverses switch x and y. So if we switch the x and the y, now your y-intercept becomes an x-intercept at 1, 0. So let's just go ahead and graph that. Now visually think about switching all of these ordered pairs, okay? So if this was 1, 10, now my graph is going to be 10, 1. All right, so remember we never cross our vertical asymptote, so it's going to follow it. Okay, this is what my logarithmic graph is going to look like. And we got that just by switching our domains and range, horizontal asymptotes, my y-intercepts, and then that one point that I have. And I'll show you how to graph this also a little bit later, but just keep in mind, I basically got my graph from my exponential function. Now, let's also think about, let's say we have y equals 10 to the x. How would I write that as a log function? Well, I would write that as a log function by writing it as when I write that, remember, here's how I'm going to write it. So I write this as a log. The base of the exponent is the same as the base of a log. Okay. So I kind of do my little circle thing. So I go here, the base of the log, this y is what's next to it, and then equals x. Okay, so notice, and then so basically, so we rewrote it as a logarithmic function, and then basically you're just switching your x and y's in order to get the function that I have right here. So now I would have y equals log base 10 of x. Okay, so that's why we can use our exponential function to get my graph of the log, because basically all I'm doing is switching my x and y values. All right, so let's just take a look at the last couple of questions. So this is increasing. This is also increasing at an exponential rate. And why is it increasing at an exponential rate? Well, that is because it's still an exponential function. It's the inverse of an exponential function. And then both of these are continuous functions, which means I'm not picking up my pencil at all to draw them. Okay, so if this is a continuous function, I don't have to pick my pencil up to draw either of them. Then what we also know is they're inverses of each other. So remember, anything that is an inverse of each other is a reflection about the line y equals x. Okay, now if we take a look at my graph, let's just graph my exponential function and my logarithmic function. Now let's also graph the line y equals x. Remember that there are reflections over the line y equals x if they're inverses of each other. So therefore, if I take this green line and I fold it over my black line, it's going to land on my purple line. If I have my purple line, I fold it over my black line, it's going to land on my green line. So therefore, they are inverses of each other. Or if you had a piece of paper and you're folded it along this line, these two would be directly on top of each other. And that's going to be key whenever we get into graphing logarithmic functions. Okay, so let's take a look and see how exactly we're going to graph logarithmic functions. Now, they're going to be very similar to what you have already done. Okay, they're basically nothing new. We're just adding a log there instead of having our exponential base. Okay, so number one, now what the difference is here is notice that with exponential functions, we had a horizontal asymptote. With logarithmic functions, we have a vertical asymptote, okay? And where does that vertical asymptote come from? Well, remember, we can never take the log of a negative number or the log of 0. So basically, in this case, when we state x is equal to 0 is my vertical asymptote, we can't take the log of 0, so I have to put that vertical asymptote here. And I also can't take the log of a negative number, which is why all of my values over here, okay, my graph is not on this side. My graph is only on this side because that's my x values being positive. I can only take the log of a positive number. Okay, so that's going to be a little bit different than your exponential functions. So this right here is going to be where you get your vertical asymptote. Okay, so your h value is now your asymptote instead of your k value. All right, so this is where you're going to get your vertical asymptote. So all you're going to do is take what's inside the parentheses and you're going to do x minus h is equal to 0 and solve. Whatever that h value is your vertical asymptote. Your graph is either going to be on one side or the other side, okay? So remember, because I cannot take any log of a negative, it's going to be on the side of the vertical asymptote where all of your log values are positive, okay? Your a value is still the same. This is going to give you your vertical stretch and your vertical shrink. And your k value is still going to be how it moves your graph up and down. Now, remember the domain and range are switched here. So in this case, the domain is restricted. Okay, it's going to be on one side or the other of your vertical asymptote. In your range, since we flip it's the inverse of an exponential function, your range is the same as the domain, which is negative infinity to infinity. Now, let's just take a second and look. B is the base of your graph. Let's take a look and see what our graph looks like if we have a base that's bigger than 1. So let's take a look at y equals the log with a base 2 of x and y equals the log of 1/2 of x. Now, if b is greater than 1, so if this right here, this value is greater than 1, the graph moves up and to the right. If your base is a number between 0 and 1, it moves down and to the right. So let me just show you what I mean by that. Okay, so number 1, let's take a look at log base 2 of x. So notice here, the graph, as you're moving along the graph, it moves up and is increasing to the right. Okay, that's whenever you have a base that's bigger than 1. Notice when you have a base that's smaller than 1. As I move left and right to the graph, my graph is going down into the right instead of up into the right. So if I were just to draw a quick picture here, that's just going to show me right here the graph is moving up into the right. If I were to draw a quick picture for the 1/2, it's moving down into the right. Okay. Now, also, this is going to be really important whenever you're graphing them. Y equals log with whatever the base is of x, and remember, b of y equals x. They're inverses of each other. So basically, how did I go from here to here? I was just rewriting as an exponential function. And that's actually going to help us to graph these, because it's going to be a little bit confusing to graph y equals log with a certain base of x, which you can actually do, but it's much easier to graph an exponential function. Remember, I can rewrite my log as an exponent, which is what I did right here. So just as a refresher, you don't go, you're going to go, this is the base of your exponent, y is your exponent, equals, this is what comes after the equal sign, okay? So they're inverses of each other, so if you rewrite your log as an exponent, you're going to use that to help you graph.